and I'm with
Matt Vines.
yeah, Matt is one of our trainers, and most of you know me as well. Digital dentures, I think, is a really interesting topic because so many of us have digitized so much throughout, the last 10 years or so. But before I get going, actually, will everybody just kind of type a Y if you can hear me? Or N? Well, if you can't hear me, you won't type anything. So just type in a little bit here so we know that you can hear. Are they hearing? Looks like they're not hearing. Please type yes if you can hear in the box, which will...
Over here.
Okay, great. So let me just back up a little bit. What we'll do is we're going to give you the full presentation, and you can type in questions at any point in time. It will probably save the questions for the end. So getting back to the meeting now, digital dentures, I think it's something that is going to really hit in 2017. I'm expecting potentially many new output devices, discs and things of that nature, many more libraries of denture teeth and 3D printers as well will play a role in our manufacturing of digital dentures as we move forward. But what I want to do with you this morning is just show you a short PowerPoint on digital dentures. But before I do that, let's move along a little bit here. So for our agenda, we'll go through current digital denture protocols and then the digital workflow, and we'll take a look at two CAD solutions, those being 3Shape and Gerbuck, and then what's needed for the digital workflow, models, wax rims, scans, etc. And then the digital fabrication process we'll look at as well. And then Matt will take over and he will demo the 3Shape CAD of a full upper and lower denture. So moving along here, are digital dentures ready in real time today? And I think the answer to this question is yes. I'm not 100% sure that we'll see all of our dentures moving to digital very quickly, but for those of you that want to embrace digital dentures, I think we have most of what we need available today. I definitely think between now and I think come Chicago, there'll be a lot more introductions into discs and things of that nature to accommodate milling and milling strategies and things like that. So I want to first review with you the 3Shape protocol. 3Shape launched a denture CAD software not that long ago. And to go ahead, what we need to do is obtain final impressions. And from that, we have our articulated casts, and we would go ahead and follow our standard protocol for base plates, and then the dentist would get final vertical. Are we okay?
Hold on 1 second, they're not seeing the PowerPoint here, so. Oh, there we go, sorry. Let's go back here.
Okay, go back.
Yeah.
Okay, so actually this is the agenda, which we already went over verbally. I'm sorry that you guys didn't see the PowerPoint. Hopefully we're all set now. So I do believe dentures are here. Digital dentures are here. And so when I look at digital dentures, actually, there are several companies that are marketing digital dentures, but I think what's needed is a protocol that doesn't change what dentists do clinically. Not much has changed clinically in denture fabrication. What's been done in the operatory has been going on, I could tell you, for more than 40 years. And for 40 years, dentistry has looked at ways to reduce appointments, but nothing has really caught on because it always seems to compromise the denture. And there are currently some existing systems where they eliminate try-ins of dentures. And, I think those digital workflows are just not working well because the try-in is a necessary piece of the puzzle. It's a necessary piece to get a quality result. So 3Shape developed a process, which I'll share with you now, where the clinical procedures are very similar to our existing analog workflows. So because we're going digital, we don't have to change what the dentist does. So first of all, we get to a point where we have final impressions and the dentist has taken bites with a bite rim and mark the bite rim. And then we go ahead and we obtain scans of the model, and then we'll also scan the bite rims on the models. And from there, Matt will show you how we go ahead and we design the final setup. And it's pretty interesting that with just a push of a button, how a wax up gets completed digitally. And then through print technology, we can go ahead and 3Shape enables us to create a single STL file that includes both the teeth and the gingiva, or the what we would consider the base material. And something that we're actually pretty excited about right now is this printer from Formlabs on the right is a solution that is available now. It will facilitate manufacturing a try-in denture. Excuse me, I'm a little cold. It's incredibly cost-effective. It's easy to use. The materials are cost-effective. It's readily available now. And I expect we'll put out a what's going on this printer within the next week or two. So you can learn more about that as a side note. But at any rate, so we go ahead, we have our setup, and like I said, 3Shape enables us to capture, to create either one STL file or a second STL file. This particular STL file where we have the try-in, it's made the teeth incorporated in the file. So when we print a denture, we print the entire tooth and base portion of this. And this can be sent to the dentist, and we can add some pink wax or pink acrylic to this to give a better effect on the anteriors. And this gets tried in the mouth similar to a wax up. Now, one thing that may be slightly not as good with this is the dentist doesn't have the ability to move the teeth. He could certainly grind on them and shorten them, or he could add composite to them and lengthen them to give us some idea of changes necessary. And I think this workaround is satisfactory. I don't think it creates any significant problems to us. Then once he does a try-in procedure, the dentist can send it back to us, and we can go back into the CAD. We could rescan if he makes changes on this try-in. We can rescan that and then reset our teeth accordingly. And then we have the ability to go ahead, select the teeth from the library. And, you know, all of these softwares now, or the two we're talking about, the Untitled and the 3Shape, have several different libraries of existing denture teeth we can use. So we then go ahead, and now we would have two separate libraries where we would make our final restoration. And this base could be milled, or this base could be printed 3D, and it would have sockets for the denture teeth placed in the base, so that after the base is milled, we would then go ahead and take the denture teeth and cement them into the base. And this is really what it would look like. So we have our milled base or a printed base. We'd mill both sides. Now when we utilize the 3Shape protocol, this first picture, the top picture on the left, shows the tongue side of the denture had been milled first. And the 3Shape protocol calls for, once you get it to this point, you go ahead and you cement in all the teeth. And then you go ahead and you put the disc back in the mill and you mill the bottom of the denture. And this will also mill teeth that were too tall to fit between the occlusal plane and the edentulous ridge. In this particular denture, the teeth were short enough that none of the teeth were needed to be milled. Another thing that's going to be coming along is we're going to get more and more materials on printed bases, and we'll be able to print these much more quickly than milling. We'll be able to print multiple dentures at one time. I know there's several companies working on materials today to make the materials aesthetic. I don't think we'll have any fibers in any of the print materials anytime soon. That seems to be a problem for printing. But, you know, I think printing will be a viable product, certainly for the economy denture. and we can go from there. So that's it on the 3Shape, and Matt will show us how that works. And now what I wanted to do is go through the Gerbach digital protocol, because this is a little bit different, and this offers us some unique features that are different from the 3Shape process. The beginning is exactly the same, and again, the clinical procedures don't change for the dentist. He'll get his initial impression, custom trays, final impressions, final models, base plates and bite rims, and he'll do that try-in of the base plates and bite rims, get the proper vertical, get landmark areas, some midlines and cuspids, things of that nature, get the length of the bite rim to where he wants his incisors placed. And then we go ahead and we scan all that into a scanner, and we go ahead and we design the final case. In this system, on Gerbach system, it enables us to either automatically select from a library of teeth, so the CAD will select what it believes to be the best tooth, or we can override this feature in the CAD software. And it's also possible to do the same thing in 3Shape as far as take an automatically selected tooth or override it. And from there, what we do, what's different, is we're going to go to a wax disc and physically mill a wax base. And you can see this on the bottom right. So this material is wax. It's not acrylic. And from there, what we do is we simply go in and we can cement in all the teeth that were selected, of the particular mold selected in the software. And if the teeth do need to be adjusted for vertical height, Gerbach has this fixture that holds the denture teeth in a card and mills the bottom of the teeth accordingly. So you'll then, mill the bottoms of the teeth, you'll have the wax base milled, and then you just cement the teeth in accordingly. And then that goes to try in the patient's mouth. And then that's where the digital aspect of this process ends. Now, this has some advantages and some disadvantages. I think one of the nice advantages is that you go ahead and you can do conventional processing. And if you have dentists that, for instance, are insistent on Lucitone 199 or insistent on, packing dentures through a injection system, you can use any system you would like or any material you would like to process the denture. And so processing goes back to analog technologies, and then finishing your denture, same thing. You go back to your analog technologies. So looking at the two systems here, I set up a little chart so we could get a handle on where we're at when we do a comparative analysis of these two particular systems. And again, both of these systems don't require the dentist to change any of their protocols. So currently, and I would say I put effective today's date because I know all of these companies are working on improving the CAD and what they can do. But right now, single dentures, Gerbach system is only capable of doing an upper and lower denture, full denture together simultaneously, whereas 3Shape you could do just one arch at a time or both simultaneously. Gerbach gives you the ability to do a wax try-in, which dentists are used to. In 3Shape, we need to go to probably a printed plastic try-in. Single STL file for the entire denture. Gerbach puts out only the base because their intent is that you're going to wax a mill base and then place the denture teeth in that. Whereas 3Shape gives you the ability to have an STL file for the entire denture as well as the base. And obviously just gives us the base only. So both of them enable digital reduction of the tooth, of the apical side of the tooth, so that it fits into the interocclusal space between the ridge and the occlusal plane. And they both have multiple libraries of existing denture teeth. And automation for the final base is not available in Gerbach's solution at this point in time. Like I said, you go ahead and you process, whereas in 3Shape, you can go on to milling and or printing. So that more or less gives you a couple of viable systems that are available today in somewhat of an abbreviated synopsis of what's available. So at this point, what I want to do is I'm going to turn it over to Matt. And Matt's going to take a physical case in utilizing 3Shape, go ahead and show you how he goes about doing a virtual setup and wax up. Okay, Matt, it's all yours.
All right, guys. So first what we're going to do is we're going to go into 3Shape, and we're just going to start from scratch here, where we start with the scanning process, just so you guys can see that. It's a very simple process. There's only 3 scans that we have to do, the upper, lower, and then obviously the wax rim or the bite block, whatever you have. So first we're going to go ahead and set up the case just by opening up a new case in 3Shape and selecting the teeth that we want to do. For this case, it's going to be a full upper and lower, so I'm going to choose all the teeth on the upper and lower arches. Okay, and then we're going to go to Anatomy, and we're going to choose the denture teeth, which is the last option on there. And then we're going to go ahead under Gingiva and just select it, and it's going to automatically select that denture scan for us. Okay, I'm going to go ahead and name this real quick. And we'll get on to scanning. So the first thing in the scanning that we're going to do is we're going to enter in the lower jaw, as we see over here on the left. Just like a normal scanning procedure, it's going to give us all the indications of what we're doing on the left. We have our main workflow at the top here, which we can see we're just going to scan those 2 arches and then the wax rim and go on to design. So we're going to go ahead and just start the scanning process. And there's no selection to be done in this stage. It's just going to scan whatever raw material you have inside the scanner. So you want to make sure that everything that you're going to capture is obviously noticeable by the scanner at this time. What we do suggest, though, is for the wax rim or the bite block, you want to go ahead and powder that or spray it with some sort of CAD spray to make sure that you can be able to capture that, because the wax tends to refract any of the laser light, so it's not going to be able to capture that as accurately. Even with the D2000 and D1000, the larger scanners, it still tends to refract, so just kind of having some sort of spray or what have you, like they have on that little icon up here, it just helps to maintain the accuracy of that bite block. And these scans do take a little bit longer than a normal scan because it's capturing the whole arch, and it's, there was no selection process done, so we can't really accurately scan certain areas. It's just going to scan whatever it can as accurate as it can. So it's going to take a little while for these scans here. There are options to trim the scans, but usually I don't trim the scans when doing the denture setup, just because it's not necessary. The base is already preset for us, and I like to use those landmarks in the bases as well to kind of help align the bites. So I don't use the trimming option during these scans here.
So just for your information, we're scanning in a D800.
So yeah, it's probably taking a little bit longer for the D800 than
Than a
the
D2000
or even the 900.
Right.
Yeah. So it wouldn't be this long normally, but this one's a pretty old one.
They can see this, right? Oh, they can't. Oh. While we're scanning, maybe we'll answer some questions rather than just having it all quiet. Somebody asked if the webinar will be recorded and available on YouTube. The answer is yes. All of our webinars are now recorded. We run webinars every month, once a month. They're all recorded. Okay, Matt, are you set?
Well, it's right now it's just in post-processing. So
Okay, that's fine. Yes, you can't see us. We didn't put on a camera.
That was a while ago. That was back at the beginning here. All right, now we got back. So post-processing does take a little bit longer than normal because there's a lot more information going into it. So once we get past that, then we're just going to go on to the next step. Again, I don't like to do the trimming, so I just skip past that and go on to the next. We're just going to have us insert the maxillary arch or the upper arch. So I'm just going to swap out my models here. And then while that's scanning, we'll go ahead and answer some more questions here. Should we start with this one, Bob? Print to mill. Which one is more accurate?
As far as accuracy is concerned, print or mill, I really think the accuracy of a denture, both will be more accurate than a conventionally processed denture. Because the denture acrylic shrinks, and generally speaking, the accuracy of the fit of a denture to a model is not great after curing. So both will be more accurate than conventional dentures.
You're still going to have a little bit of an accuracy with the wax because wax itself tends to shrink. So if you're taking it from the lab to the doctor's office, it's traveling, it's hot or cold, it will shrink.
Yeah, but we actually process when they process to the model.
Yeah, okay.
The model is the base, not the wax.
Mm-hmm.
Okay. Do the libraries match? Yes, I have a question here. Do the libraries match existing tooth charts? Like Dentsply Ivoclar. Yeah, there are different libraries for different companies, and they are of existing teeth. So the answer to that question is yes. What material is available for milling? Final bases. This is something we're looking at right now as far as materials are concerned. It's our ambition and our goal to go ahead and have all of the most common materials available in disc form. For instance, like it'd be a goal of mine to have Lucitone 199 and things of that nature. So I think we'll have a wide variety of base materials in time. So actually, we had already mentioned we're using the D800 scanner. What is the average time for the scan process? I don't really know. This looks like this scan with the D800, which is older. It's probably takes twice as long than this scanner.
Yes, you're not doing the individual die scans and you're not doing a bite scan, so you're going to save a little bit of time there. But it's going to be a good amount, about 5 to 8 minutes normally. So it's like a typical scan case, only you don't have all the processes. So it still takes the same amount of time. If you notice, we started at 11:25 and it's 11:28 right now. So we've already gone, or 11:29. We've already gone 4 minutes in, and it's just started post-processing of the second scan. So it's probably going to take about 8 minutes for the whole scanning process.
Okay. Yes, the accuracy of the D700 is adequate for dentures. And somebody else had asked if we could scan impressions. And yes, we can scan impressions for digital dentures in 3Shape. I don't believe we can scan impressions for the Amann-Gerbach workflow.
And in the G2000, you can scan both right off the bat. It's still going to be the same process. It's not going to start the second scan until the first scan has started post-processing. So you save probably about maybe 30 seconds there when you don't have to do any selection processes. Other than that, it's the same type of workflow.
Most of these questions are similar. A lot of you have the same questions.
You went up. That's why. There we go down. Yeah, there we go.
Okay. This is.
But yeah, let's get back on to the next part. So Right now the upper jaw is done, so we're going to go on to the next stage, which is going to have us attach the bite rim to our models. So I'm going to go ahead and put the lower on my bottom portion. So I'm going to put the lower on first. I'm going to add my bite rim or bite block or wax rim. Go ahead and attach that to my model, and then put the upper model on. So it's kind of a traditional look at the models here. So I'm going to go ahead and put this in. Start the scan.
Okay, while that scans, here's another good question. When modifying the bite after designed and milled, do you rescan adjustments? Do you rescan adjustments that your doctor made and start over designing, or do you adjust design from your original design? Okay, so there's two different systems we're looking at here. So within 3Shape, if the bite was off on your original printed dentures and the dentist changes that, you can just rescan the vertical and then go ahead and move your teeth accordingly to accommodate the new vertical. And if you want, you could go to a second set of printed dentures, or you could go to a final denture on that situation. Within the online Gerback system, you could go ahead and rescan the new vertical as well and go back to your original setup, move those teeth around, and then go ahead and remill your wax bases and get that ready to process as well. I think actually with vertical changes, the 3Shape system might be a little bit more streamlined for us because we don't have to mill that wax base again. Yeah. The average printer price, I normally don't quote prices in webinars, but that printer from Formlabs was selling now for all in, I think it's $6,500 in the printer itself with no materials. The all in is starter kit training and a whole bunch of other things that you'll need with the printer. A curing light is $6,500.
Okay. So now you can see that the wax rim has stopped scanning and we've got post-process here. And this is just a typical wax rim that we had just made up for this case, but you can see that we had our midline kind of marked out and we have our canine points marked out as well. So what we're going to do now is we're just going to go ahead and align the two scans that we did prior to this to these instances. And this is why I don't trim off those scans, because we need as much as possible to align it to. So lower is pretty good because we can pick some individual landmarks that we can go ahead and align to, and it's very easy to align to. But the upper, since it's on the top portion of that, it's reaching the limitations of the scanner that we have here. So there's a little bit less that we have to align to, but really definitive marks that I can just go ahead and mark and get those set up together. Now once I have those all set, we have everything aligned and our scanning is done. So all in all, it'll take about 10 minutes for this case, but this is on a D800, that's an old case, so
Roll scanner.
yeah. So normally a typical scan would take about 5 to 8 minutes to do. So let's go ahead and take a look at the design from now. So the first thing that we're going to do in our design phase is we're going to mark the occlusal planes. So we're just going to pick on 3 individual points that we have for our occlusal plane. So we're just going to click on the 3 flattest points that we have there. Just make sure it's nice and lined up. If I wanted to, I can go ahead and adjust the pitch of my occlusal plane. And I can also adjust the sagittal plane so that it's lining up right with my midline. So we want that to be exact as well. Okay. Now what we're going to do is we're going to hit next and move on to our characteristic points. So now we're taking a look at our jaws kind of exploded here, and now we can mark individual characteristic points on each of these arches. So first thing we're going to do is we're going to look at our maxillary points. We're going to start marking with the tuberosity. So we're going to start with our tuberosity, then we're going to go to our incisal papilla, and then tuberosity number 2. Then we're going to look at our canine points. I kind of just take a look at where my marks were, where the doctor wanted us to have those canine points, and mark those on the ridge as well. On the lower, we want to be a little bit more individualized with our points, our characteristic points. We're going to start with the retromolar pad, which is going to be on right here, and then we're going to mark on the buckle and then the lingual portion of that. So we want to go ahead and mark on those extents as far as we want. Then we're going to go ahead and do the central ridge point. Do the same thing on the other side as well. Retromolar pad, do the buckle, and then the lingual points. Now we're going to go ahead and mark our canines, which we can't really align these two together here, so we're just going to go off based off of these instances. Just going to go there. Once we have all our characteristic points set up, let's double check to make sure they're okay, and we're going to go on to the next stage. Next stage is going to have us draw our boundaries. So the boundary is just going to be the boundary of your base plate, so you're just going to go ahead and click on this little button here, and go ahead and either left click and drag to kind of draw out that boundary, or you can do a series of clicks to kind of go ahead and customize that a little bit further. So I'm just going to do a rough sketch here, just kind of going up and around those tendons, make sure not to get it too close to those areas. We'll fix all the errors that I have there later in a little bit. So just do a quick sketch first. Once you do that, you do have all the individual points, and you can pull out all those points to kind of customize that area, or you can just right-click on a point and go to the Fast Edit spline and just make the adjustments as you see. So I'm just going to go straight across on that one, and bring this one there. I'm just going to go straight across on this one, and straight across on this one as well. Okay, maybe I'm a little bit too high on this tendon. Just come down there. And come back a little bit over here. Look good, Bob?
Yeah, I think for the purpose of the webinar, you know, you all know where you want the periphery and the denture to end.
It's very simple to draw this. So
I think that's good.
Yeah. Now we're going to go on to the lower boundary and do the same thing. We're going to click on the little outline box here, and if you want, you can go ahead and do the series of clicks, but I'm just going to left click and draw just because it's a little bit faster, and then we'll make any changes afterwards. Okay, so right click on the line, do Fast Edit spline, and then go ahead and mark where you want those areas to be. So go ahead and drag that down a little bit more. And just customize it how you see fit. Too far out that way. Okay, looks good enough. We'll fix this area here. There we go. All right, now we're going to move on to the next stage. So next stage we're going to go into the blocking out or waxing out our undercuts here. So the first thing that we need to do is we need to determine the path of insertion for our models here. So first I'm just going to go ahead and look, make sure I can go ahead and tilt it back a little bit more. So we're going to go ahead and tilt it like that to minimize the undercuts here. And I'm going to hit the Set from View button to go ahead and maximize my view from this angle. Now anywhere that was in an undercut area is now going to be appearing in yellow, and that's okay because that's within the 0 to 1 millimeter range of undercuts. Now we can go on to next, and we can do some wax trimming. So if you wanted to, you can go ahead and kind of wax out those undercuts to kind of prevent them from being there. But since they're yellow, we don't have to worry about these ones. They're not going to be impeding too much. Next, we're going to do the same thing, but this one's going to go ahead to the lower. So we're going to go ahead and look at it like this, straight on, and then hit Set from View. Now with this one, we will have undercuts on these areas here, which we see in orange. So we do want to block out those ones, but we want to be careful not to go too far to the edge. So when we go into our wax trimming, what I usually do is I'm just going to go ahead and take my smooth tool, and just get a smaller one, and just kind of fill in those areas with the smooth tool. And that just kind of helps to kind of blend this into that area there. Turn this on just until the orange goes away so that you have the yellow there. Make sure that we're not going to that boundary cut where we had it before so that we're not running into any areas where there'll be sore spots. So now everything else should be either purple or yellow on our boundary lines. And once we have that, we're good to go. On to the next stage, we're then going to go into the actual full denture design. Here we have at the bottom of our screen is going to be the area where we go to select the library of teeth that we're going to be using. You can choose your provider down here. You can see Vita, Predenta, Allure, Condyliforms, 3Shape, or the default ones they have. You can also choose individual options over here based upon your anteriors and your posteriors and what your individual types are. So we can go through these and kind of change what kind of denture setup we want, whether it's going to be universal, whether it's going to be a delicate look or an individual look or vigorous. You can go through each and every one. Under these, you'll see the distances that are kind of applying to the designs here. This talks about the distance of your anteriors and then the height of your anteriors over here. And I believe this is the central width as well.
Yes.
So those should match the individual options that you have on the cards that kind of go back and forth. So you choose the individual card, it has the individual heights here. So you can choose your anteriors and then your posteriors as well. So we're just going to go ahead and just start with a delicate setup here and then hit apply to apply the changes. Okay, once we have our setup, we'll take a look at it, and if you want to make any changes, like if we wanted to move the midlines over a little bit, you can go ahead and do that to kind of match up with the central papilla, or you can just leave it as is because of the setup. But you do have those characteristic points kind of map out these individual areas so you can help to kind of line up your canines or what have you, but usually they just tend to get in the way. So right now what we're going to do is we're just going to set up our teeth and get them in a sort of form. So I'm going to remove this plane there and just go ahead and set up our teeth using the design tools. The first tool over here is just going to help to adjust the whole occlusal plane adjustment. So it's not going to be one arch or the other. It's going to be the whole arch together, okay? The second arch is going to be the arch setup, which allows us to customize individual points of the arch. Here you can have symmetric design or show your overlaps, which are areas where your denture teeth overlap. So you can go ahead and prevent that from happening. Like over here, you can see the overlap is happening. So we're going to go ahead and sort of pull these areas out or up to kind of help shape these areas. If we make a change and we don't like it, we can always undo, just like the other ones. So if we want to kind of pull these in, we can go ahead and pull the anteriors lower in a little bit, just to kind of adjust this setup. It is a little tricky to get used to because these units do want to snap back and forth with each other, but you just kind of have to work across this unit. Once you have the teeth set up, you can then move on to the next one, which is the manual arrangement, where you can arrange individual teeth, kind of does symmetry along the instances, or you can turn that off. And here we can kind of rotate the individual teeth or move them into individual positions. So it allows us to kind of customize the setup of the teeth a little bit better. Okay. I'm not going to go through the whole process of setting up the teeth. We just want to look at the main workflow. But the setup is there, and the tools that we have are very similar to the full arch cases that you would design normally in 3Shape. So I'm just going to go ahead and rotate these guys out a little bit. Now, normally with these setups, you do want to leave a little bit of space in between the teeth, because if you do have the teeth coming in together, it's going to give you a little warning when you go into the next stage, letting you know that you have overlaps in between the teeth. And we'll see that warning next. So I'm just going to go ahead and say that's okay, and move on to the next stage. Right now it's just going to take a look at the instances and let us know if there's any teeth collisions, and it's going to tell us what teeth are colliding. So here you can see all the teeth that we didn't fix or spend time to give space. It's just going to have these instances. Now you can go ahead and ignore the problem and continue, which is what we're going to do, which means that you would just go ahead and adjust the teeth.
The context of the teeth, but really I would suggest at this point you would want to fix these collisions.
Yeah.
It's easier to fix the collisions here than it's going to be to grind in the context of all the teeth.
Most definitely, and unfortunately we're kind of strapped for time, so we're not going to spend all that time doing that. But the basic workflow is just set up your teeth and then you move on to your base design. So the base design, again, allows us to edit this spline if we want to. And here we have additional options which allow us to give a window to the base if you wanted to give a little bit of a window onto the roof of the mouth here, or if you wanted to add extra relief stones. So if you wanted to add a suction area, you can go ahead and add a suction area at this back portion here to allow for extra grip. Once I can get down, so you can add added relief zone on these areas. Okay, the added relief is going to be added by the relief zone is just a typical 0.15, and this is just going to add that a little bit more to that area. Again, you can adjust it just like if you were doing a gingiva design on an ISO bridge or an all-on-4 type case. It's the same sort of instance. You can delete the spline or add a spline, whatever you want to do. So once we have the basic design or outflow go, we can go ahead and hit next, and it's going to allow us to shape that gingiva design, similar to like we just said the ISO bridge design, where you have the gingiva and you can kind of sculpt it to meet up the individual papilla areas of the teeth. Now the good thing about this is it's a little bit more adaptive, because if you take a look at the teeth that we see on here, I'll rotate it around, but you'll see there's kind of like a green spline around the bottom of the teeth, and that's where it's going to tell the gingiva to kind of snap to that anatomy portion. So it's a little bit more intuitive of a pre-design. Unfortunately, it won't let us do that until the next stage, though, because it doesn't do the sculpt.
Do the same to the lower.
Yeah. So now we're just going to do the same to the lower. And here's what I'm just telling you about, is that green line that we see here. So the tissue is going to go all the way up to that green line. Whereas if you've ever had to design the gingiva on an ISO bridge, you have to manually sculpt that area. It can be a little bit tedious. Let this process for now. Take a second to answer some questions a little bit later. But now you can see we have our dentures set up here. So now we can go ahead and do the sculpting, which is just like the gingiva design, where we can go ahead and use the morphing tool to kind of push and pull certain areas, or we can use the wax knife tool to kind of add and smooth certain areas out, or if you wanted to give it a little bit more characteristic, you can kind of smooth it back down. All right, you can do the both just by clicking on one or the other, just switching back and forth like if you were doing a full mouth case. Okay, and it's nice because it does leave that little green area on the teeth, so you can kind of see where they should be matching up. Kind of gives you a nice little guideline to design your papilla to. Once you do that, you can then go on to the next stage, which is going to allow us to choose what kind of manufacturing we're doing. So this is where we're talking about the different types of manufacturing that Bob was talking about, which is the glued in teeth with the basal reduction, where it has you mill the top portion out, you glue in the teeth, and then it mills out the bottom portion and cuts out the denture teeth along that portion there. You can do injection molding, which is the full individual denture, which allows us to kind of print this all as one. So the teeth are now going to be printed out of the same material kind of at the same time as the denture, which is going to be the optimal workflow for the 3-shape process. You can choose glued in calm, which is kind of the same instance as the basal reduction, or you can choose in the glued in teeth matrix, which is sort of similar to the Amon Gerbach, where the basal reduction of the denture teeth is done separately from the milling of the denture base. So that'll be 2 individual files. This is where it's going to give you those teeth to kind of mill out those areas where you're not going to mill it out versus gluing it in. So the glue in space just tells you about the space settings that we have in there. Typically we just leave these as the normal settings. It tells you about the minimum thickness under the teeth. For the glue in teeth matrix, you probably want to increase that, but for the basal reduction, it does not have that option to reduce that, because remember, the underside of that denture base is going to also be milling out the bottom side of that tooth. Then you have the option to do your drill compensation, which is going to be done for drilling. So with a 1 millimeter burr, you do want to be a little bit more than 0.5, so it would be 0.55 for a 1 millimeter burr. Go ahead and preview, and this is just going to show us what these individual pieces look like. So with the glued-in teeth matrix, which is sort of a similar way to the Aman Gerbach, we can go ahead and see what these look like if we turn off our models. And just let it process for a little bit. While we're doing that, I was going to answer some questions here.
Here's a very interesting question. Are the scans only done on a cast, or can they be done on a patient with an intraoral scan? Scott, this is something I'm really not sure of, because it's something I'd like to really dig in, and it needs to be tested. Because normally when a dentist takes a stock tray and border molds it, he's compressing the tissue, and then the tissue gets compressed more with the impression material in it. And I'm not sure if a denture will fit better or worse if the tissue is at rest with an intraoral scanner. So I don't have an answer for that, but for now I would suggest that a conventional impression would be best until we determine the accuracy or inaccuracy of the digital scan. The materials, as far as repairing these denture materials, the base materials are made out of acrylic, so they should be as repairable as any other material. However, if you're getting involved in printed bases, we're probably going to need different materials to repair those materials, because those materials are more composite than acrylic. Kent had asked what type of cement is used to cement the teeth into the final denture base. And this is an ongoing project in R&D right now. There's a lot of testing going on cements and different viscosities of cement as well, which are being adjusted so that we can get an exact best-in-class solution for cementing these teeth in. Can we do characterized setup? Stacy, I'm not really sure what you mean about a characterized setup, but if you're saying can we characterize a setup to have a diastema or to rotate teeth in and out, all of that is very possible. If you're talking about characterizing the acrylic base with different colors of acrylic, we're not at that point where that can be done. However, at some point in the future, I'd assume that print technology will grow so that we can have multiple colored base materials in a printer.
I know they have some bases that have sort of like the vein look into it.
Yeah, for milling, there are denture base discs available now that have the veins in them, but I wouldn't consider that necessarily characterized.
Yeah.
There is nothing, Scott had asked, can these be used with metal base with a removable partial denture? No, we haven't gotten to a point where this technology is just for full upper and lower dentures.
There is an RDD software that we could take a look at another time. It's a very easy workflow. It's very something that a lot of people are doing nowadays.
For the partials.
Yep, for the partials.
But it doesn't take care of the tooth setup and the dent and the acrylic. No. Yeah.
Those have to be taken.
I think at some point, there'll be things we can do digitally to do the setup on partials, and then probably have a different workaround to get the acrylic in. The difficulty with a partial is that we have to get the acrylic to flow through all of the undercuts made in the partial to hold the acrylic to the chrome cobalt.
Mm-hmm.
So, yeah, do we need a posterior palatal seal on the maxillary cast? Daniel, I think yes. A post-dam makes logical sense, and I think it's actually very easy in Matt's last step that you can turn the model off, and through the add-on tool, you can add a post-dam to the back of the denture, however formed in whatever shape you'd like or design that you would like. You can add that by hand, or if you would like, as you normally would, you might want to trim your model before scanning for that post-dam area. So it's just scanned and then it fills in automatically. Here's a question from Alan. Do you have to mill the denture teeth if only making a single arch, opposing natural dentition in 3-shape? The answer is that would depend on whether or not there's enough intraocclusal space between the ridge and the opposing occlusion to fit the full length of the denture tooth. If there is not, then actually I didn't go into detail, but I'll talk a little bit about that right now. When you go into milling a denture base in the 3-shape system, what you do is you first mill the tongue side of the denture, or the outer portion of the denture. Then you would go ahead and cement in all of your teeth. And then you put your disc back into the mill and you mill the tissue side. And as it mills the tissue side of the denture or the disc out, it will mill the teeth as needed. Okay. Kurt asks, can the denture be outsourced to CAP? Not at this time, but it's something we're hoping to be providing in 2017, a denture solution, a digital denture solution. Alan is asking about the printer. Is this a Formlabs 2? Yes, it is. It's a little bit more dental ready, though. There's been some changes made to it to be a little bit more accurate for dentistry. Are we milling the teeth or using card teeth from the matching company you choose? In 3-shape, we just go ahead and we mill the physical teeth after they're cemented in, as I had described.
I think you might mean, are you milling like the teeth from scratch? So in that case, no, we'd be taking the denture teeth and putting it into there and then milling out the bottom of the denture.
And it mills the tooth at the same time.
Yeah.
Okay, let's go back on to see where Matt is at.
Okay.
And we'll get to more questions in a little bit.
So we'll take a look at what this looks like here, and you can kind of see the underside. This one did not need to be milled on the underside because of that instance, but we can take a look at how this is sitting in there. You can kind of see the kind of keying system that it has based upon those denture teeth.
Yeah, so this base now can become an STL file that can be printed or it could be milled.
Mm-hmm. That's exactly it. Or we can choose it back to the injection molding, which goes back to the instance that Bob was talking about at the beginning of the slideshow, where you print these both as one solid object. So the two solid, the base and the teeth are kind of printed as one. And then you just add that acrylic or that pink wax onto the interiors to kind of give it a little bit more aesthetic features when trying it in.
Yeah, so now it's converting the file to just a single. Rather than having two files, we now have one on the lower.
So yeah, the lower is now all one file here.
So that's ready to put in the printer.
Mm-hmm. And that's it. Just a matter of choosing the different type of manufacturing settings that you have. And you go on to next, and it's going to go ahead and create those manufacturing files for you.
Okay. For occlusion, balanced or non-balanced, Daniel, you can set up the occlusion any way you'd like. We've already talked about cement. So which mill are we using? Really, we can use any mill. We have not really optimized any of the mills to mill bases really rapidly at this point. One thing I'm kind of looking forward to is Armand Gerbeck just introduced a new series of Ceramills, and what they did in the Motion 2 is they increased the spindle kilowatts to 75 watts. And it's almost triple the power of the old mill. So I'm very anxious to see if we could go ahead with that more powerful spindle and put in a wider diameter tool to do roughing really fast, like a 4 or 5 millimeter diameter, where normally the largest tool we put in a mill for dental is 2 millimeters for crown and bridge. So, it's going to be about time, how long it's going to take. But we've milled some bases in Rollins. It's taken a long time. I don't think the Roland spindle would be something that we will be efficient enough to do this on a regular basis. So we need a mill with a pretty heavy-duty spindle for this protocol. How long does it take one to run a print to print a denture?
It really depends on the printer that you're using, but the Formlabs that we were talking about, if you're using a typical denture like this, it's probably about, 40 to 45 millimeters tall? Or not even, no, 30, yeah. 35 millimeters. So it's probably going to take anywhere from, 3 to 5 hours to print, 3 being a little bit more conservative. But so I would say about 5 hours to print one instance, but you can probably get a good
4 or 5
dentures
in every in about 4 hours.
In about 4 hours.
Yeah, so it's probably an hour a denture. Mm-hmm. Can a hard reline be done on a printed or milled base? Certainly on a milled base. Printing, I'm not really sure. Again, we're going to have to find compatible materials for the composite materials that are in print technology. At this point, again, I'm thinking that a final printed base is more of an economy type denture. Because I don't think the base materials at this point are looking all that great, although we are working on trying to get things to look better. Let's take one more here. Would it be cheaper to print or mill the try-in? It's absolutely going to be cheaper to print the try-in denture. On a Formlabs, it's probably going to cost about $5 or $6 in materials, and your machine time is really not much at all because the printer itself is so economical. And I think that, let me see, one more. Can you optimize the gum wax, i.e. the frenum? Yeah, you could do anything as far as morphing and adding and subtracting to the gum material or the wax up. So you can customize that as you would like.
Yeah, you can even go on the back side of the upper. So say if we wanted to do the upper here, let's turn off the lower here. If you wanted to do the upper and kind of increase that rugate so they don't have so much of a lisp, you can go ahead and back in the design stage, if you want, where we're sculpting stage. On the sculpting stage, if you wanted to go ahead and kind of add to that instance there, it's giving us an error because we've went back and forth without it loading. Okay. So if we go back to the sculpting stage on the upper, for sculpting on the upper, when we turn off our lower pieces here, you can go ahead and just kind of turn down your instance here. And if you just want to use a slight add, okay, you can kind of see where that bottom portion is kind of copying over our rugate, so we can just go ahead and kind of add a little bit less intensity here, but you can just
duplicate the patient's rugate.
Yep.
That's really cool.
And you can just kind of copy that in.
Another thing you could do is you could develop your own library for a wax up, so that if you want to spend a lot of time waxing up one denture by hand, an upper and a lower, and you could put that in and create a standard wax up for your own laboratory. It's a really great thing to do. It really, the wax up falls into your denture with just the push of one button. So all the energy you put into creating that library is well worth it. And in fact, I will tell you, Armand Gerbeck has developed a beautiful library for their wax up. And somebody asked you, how long on average does it take to do a setup and wax up of a denture? Interestingly, I was in Austria a little over a year ago, and I saw Armand Gerbach's denture CAD, and I sat down to it. It was absolutely the very first time I'd ever done a denture setup using CAD, and the entire process took me 20 minutes, and that's without being very experienced. So I would suggest that it would be 20 minutes or less to do a full upper and lower. In some cases, might be a little more complex, but for the most part, it's super quick. And when we talk about digital dentures, it only really makes sense to go digital if we can do things more efficiently. And I would suggest that it's much more efficient if we can get an upper and lower setup done in 20 minutes. And also, we're not going to be grinding on the bottoms of the teeth by hand and all of that. That'll all be done mechanically through a milling process with both systems. Okay. What tooth files are used?
So the tooth files are based off the CAD system that you're using. Like 3Shape, I believe, just works with Ivoclar currently on the 3 different types of libraries that they have. If you take a look at the option in your control panel, you'll see the different tooth libraries that they have for dentures. No, I think it's under the anatomy and Pontic libraries, because when we go over here, you'll see there's a few types that...
Oh, Vita.
Yeah.
They have Vita teeth.
They have Vita teeth, which are the Physio Stars. They have...
The thing is, I know for a fact both companies are adding more and more tooth libraries to their software. So over a period of time, I expect that most full dentures will be made via CAD CAM. So all the teeth companies will be anxious to get these digitized.
So you have Candelore, Allure. All those have different types of denture teeth that we're going to be using for these setups. And if you actually try to use some of these denture teeth in your everyday designs, you'll notice that you run into some issues where it won't be able to generate the STL. And that's why, because they're specifically set up for denture design in 3Shape and not necessarily the everyday workflow teeth. So.
Okay. Well, at any rate, I want to thank you all for spending this time with us, and I hope you enjoyed the program. And stay tuned, as we'll try to keep you posted, and I'll be blogging as more happens with the digital denture. And again, thanks for spending time with us. Matt, thanks for your help.
All right, no problem. Thank you very much, Bob.
Take care, all.
All right.